In this video, we're going to talk about rotating a two-dimensional shape in order to create a three-dimensional figure. This is going to require you to use your imagination just a wee little bit. So in the first example, it tells us that we're starting with that right triangle that's pictured, and we're going to take this triangle and we're going to rotate it or turn it or spin it around line L in order to form a three-dimensional solid. In part A, they're asking us to sketch and identify that solid that is formed by the rotation. Some of you are going to have a much easier time envisioning this than others. And if you can envision it quite easily, that's great. If you're like me and you struggle a little bit more in order to envision it, here's what I want you to think about. I want you to think about that little blue triangle coming forward or at you, and then kind of going flat down below line L, and then continuing its turn so it's pointed backwards out the back of the paper, and then lastly continuing that revolution or that rotation until it returns to its original position. So from a drawing standpoint, if you are a weak drawer like I am, I'm going to think about reflecting that over line L. And as this fella turns, this piece here, that point, is going to remain exactly the same, but as this piece comes out at you and then turns around and spins behind you, it's going to create a conical or cone shape effect. So as far as the sketch, there's my nice little sketch. And as far as the name of the solid, well, I said it when I used the word conical. The shape of that is a cone. And if that little cone is lying on its side, if you prefer, you can take and you can draw the cone in the upright position if you're used to and comfortable looking at them like that. In this cone, that radius of the circular base is going to come from that 3-inch piece right there. So the radius of that cone would be 3. The height of that cone is going to come from that piece right there in the triangle, that second leg, and the height of the cone is 4. So now we can go ahead and find the volume by using our trusty volume formula for a cone. Remember, if you forget the volume formula, no biggie. Just go ahead and grab it off of your handy-dandy reference sheet for mathematics. So volume is equal to 1/3 times pi times I squared times h. And I'm just going to go ahead and use my beautiful picture that I drew to go ahead now and substitute into the formula. So 1/3 is going to stay the same, pi is going to stay the same. The radius of that cone, remember, is 3. The height of that cone is 4. And now what I'm going to do is I'm going to take, and in my calculator, I'm going to calculate or plug in or substitute in all of the rational pieces from that expression. So I'm going to substitute in the 1/3, the 3 squared, times the 4. So let me grab my calculator. I want the fraction 1/3 times the 3 squared times the 4. And when I multiply those three terms together, I get 12, or I should say those three numbers together. I haven't yet multiplied by the pi, so my exact volume here would be 12 pi cubic inches. Remember, I'm always going to leave that as exact as I can unless I'm told to round to the nearest something, in which case I would plug the pi key into my calculator and I would round appropriately. But in this particular instance, it doesn't say what to round to, and therefore I'm not going to round at all. All right, let's take a look at another one. Number 2 says instead of rotating a triangle, this time we're going to take a rectangle and we're going to rotate it around line L in order so that we can form a cylinder. Find the volume of the cylinder that's been formed. So again, I'm going to envision that rectangle coming out of the page at me, then flipping around and reflected across line L on the page, and then continuing its turn or continuing its revolution and pushing back into the back of the paper until finally it returns to its original position. So again, if you are like me and you're challenged by the drawing, it might be helpful to think just reflect over that line And again, if I think about this front piece is turning, 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 it's going, or the top piece turning, 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 that's going to form the top of my cylinder. And likewise, the turn of the bottom piece or the spin of the bottom piece is going to form the bottom of my cylinder. So again, if it's helpful, you might want to redraw the cylinder so that it's a little bit less cluttered. And in this cylinder, it looks like the radius of the circular bases is 5 inches. And the height of that cylinder is going to be the 2 inches that came from that rectangle. So my picture is a really cruddy picture, but that's okay. It just goes to show you that you don't have to be able to draw well in order to be able to do the geometry well. All right, the last piece of this wants us to find the volume of that pretty cylinder. So once again, I'm going to go ahead and I'm going to start with the volume formula. So from the formula sheet, volume for a cylinder is pi times r squared times h. I'm going to go ahead and plug into my formula, pi times 5 squared times 2. I'm going to once again go running for my calculator and I'm going to plug into that formula the rational pieces or the rational factors. So when I get my calculator out and I type 5 squared times 2, my calculator tells me 50. And once again, I have not yet multiplied by the pi, so this is 50 times pi. And my units here, they don't give me any kind of units here, so I'm just going to say cubic units. Or if I preferred, I could say units to the third power. Oh, they do give me units. If I want to, I can make that 50 pi cubic inches. But you get the picture. All right, as always, if you have questions, jot them down in the margins so that you can remember to ask about them the next time that you return to class. And I, again, want you to see what you can do with your newfound knowledge and see what you can do with those check your understanding questions on the next page.